Welcome to this project, which is all about helping you to become an advanced blockchain developer and build something meaningful applications. So, in this lecture, I am going to give you all around introduction to this project. So, first of all, let me introduce myself. So, this is my LinkedIn profile. My name is Rohit Sonawane, and I have 7 years of experience in software development and consulting, and from past several months I am mostly involved in a blockchain consulting and programming. Now I have the knowledge of Solidity, various smart contracts, AngularJS, React.js, and Android also. Okay, so in this course, what we are going to cover is that we are going to cover the mortgage calculator or the mortgage processing smart contract. Okay, if you know the smart contract and blockchain, then you will understand this project very well. Okay, for the reference, what you can do is that you can go to this mortgage calculator website, and here you'll find how to calculate the mortgage for any home and for any property. Okay, there will be like home value, down payment, and other stuff, and you have to pay interest for the particular years, right? So here on this website, that is mortgagecalculator.org, you will get an idea of what is actually a mortgage calculator or what is a mortgage processor, right? Okay, after that, for the mortgage calculations, formulas and other stuff, you can go to this link, that is wikihow.com, that calculate mortgage payments, and here you'll find different types of formulas here. So you can go through this website. They have clearly mentioned the formulas and the steps to calculate the mortgage. Okay, so what we are going to cover in this project is that we are going to focus on a simple illustrative applications to address a potential use case in the mortgage space. We are going to use smart contracts which will automate the mortgage contracts by connecting the parties and providing for frictionless and less error-prone process. The smart contract can automatically process the payment and release lines from the land record when the loan is paid. They can also improve record visibility for all parties and facilitate payment tracking and verification. They also reduce errors and cost associated with the manual process when we use the smart contract. So as in the general scenario in the mortgage space, everyone knows that there is some homeowner. Okay, he wants to buy some property, then he do the application things and like that. Okay, and the banks is there and the banker is there, then they give the loan to that homeowner for that particular property, and they set it up the things like what is the monthly premium he needs to pay, what is the interest rate for that, and other stuff, right? So this is the general scenario right now in the world, right? But everything comes under control of the bank, but in our project, what we are interested is that we are going to use the smart contract, right? So the bank system, the banker thing will be gone, or it will be replaced by the smart contract, right? And in that smart contract, all the information related to the property, homeowner, and the mortgage holder, and whatever may the internal revenue services or things, all that code will be held by that smart contract. So it is transparent to everyone, and that smart contract can handle all these things for that particular mortgage processing. So this is our project, and that we are going to deploy and in this project. So from the next lecture we will start with our basics of a blockchain, what is a blockchain and other stuff. So we will start with our basic things, and then we will proceed with our smart contracts and front end in the upcoming lectures. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in this lecture we are going to see what is a blockchain, and in this session we are going to cover the basics of a blockchain, so you can understanding the foundation of a blockchain. So you will understand the future coding and the syntax that we are going to write down in this course. So let me start with the what is a blockchain. So if you're I think if you are doing this course, you must probably know what is a blockchain is all about, but let me explain a little bit amount of data for this. So what is a blockchain? So blockchain is a type of a distributed ledger for maintaining a permanent and a tamper-proof record of transactional data. A blockchain functions as a decentralized database that is managed by computers belonging to peer-to-peer network. So what is actually this definition is all about? Okay, if we are going to see this slide, here you can see different types of networks here. So this is centralized, decentralized and distributed networks. Okay, these are some new networks that are present right now in the world. So what is the difference between the centralized, decentralized and distributed system? So in centralized system, all you know is that every node or every computer in that network is connected to some centralized system or some centralized server. So that's why it is called a centralized system. So in today's world, many of the systems that we are using over the internet are centralized system. Means that there is some server like for like some Google server at some central location, and we are accessing that central database of a Google from our computer. So that is a centralized system. Then what is meant by decentralized system, and why it is needed to make a network that is decentralized? So the main problem with the centralized system is that if the server goes down, okay, the central point where we are all connected, if that goes down, we cannot communicate with each other, right? If this central system goes down, then this node cannot communicate with this node, right? Because the central system is down and there is no medium through which I can communicate. So to eradicate this problem, the computer engineer come up with this decentralized system. So in decentralized system, as you can see here, there are different types of nodes here, right? And there are some little networks you can see here. Okay, and those little networks are connected to their some centralized smaller server, you can say. Okay, but the decentralized system has also a problem of the failure for particular nodes. Like if this node wants to communicate with this node, okay, but this node goes down, then this node cannot communicate with this node. So this is the problem with the decentralized system. But advantage is only that all the network does not goes down, okay, if there is a failure of some node in the decentralized system. Okay, that is the benefit that we get in the decentralized system. So to eradicate this problem also, the network engineer comes up with the distributed system. So this in the distributed system, as you can see that everything is connected to everything. Means every node is connected to every node, and there are multiple routes by which they can communicate with each other, right? So if, for example, if this node wants to talk with this node, okay, and for example, if this node goes down, still this node can communicate through this node with this, right? So in distributed system, the network never goes down, okay, and every node can communicate with each other, and there will be no effect of a a particular node if goes down, so network still will be alive. So that is the benefit of the distributed system that we get in distributed network. So what is a blockchain is all about? So blockchain is a decentralized and a distributed at the same time. Okay, so it is a decentralized, so there is no particular central server present in the blockchain, and it is distributed also, means every node is connected to each and every node through some network over the internet. So if a particular PC goes down or a particular node goes down, still there will be no problem in a blockchain, okay, to get a data or to send a data. Right, so this is the main difference between centralized and the blockchain systems, you can say. So as we can see in the next slide also, here you can see the same image with the computers, and the network is a distributed system, right? So here you can see it's a shared public ledger, okay, of transaction. So this is the shared system, it's a public, so anyone can see a data on a blockchain, okay, and a ledger of transactions. So each and every node has updated transactions and ledger, right? So if I download the blockchain node into my computer, I can also see the transactions of a particular person, because blockchain is a public thing, right? So anyone can inspect the transactions. So there is no hidden type of things in a blockchain. So it is all transparent and no single entity controls. So the best beauty of a blockchain is that no a particular company and there is no particular owner for a blockchain system. Means that there is no company, there is nothing that owns this system, okay, and that is the beauty of the blockchain, that no one owns the system and still it goes on, right? So we will look a little bit about history of a blockchain. So where is it come from, and who developed this, and how it came into the existence. So in 2007, a person named Satoshi Nakamoto begins the working on this concept called Bitcoin, right? In 2008, he published a white paper on a Bitcoin, and after that he started working on this concept called Bitcoin. So as many of you know the Bitcoin and what is the Bitcoin is all about. So Bitcoin is just a cryptocurrency that people trade for fiat currency. Okay, that is just a virtual currency, right? In 2009, there is a first transaction that is happened in the Bitcoin, and after that, the Bitcoin journey started from year to year. And as you many of you know, in 2017, Bitcoin price is like about $11,000 US dollars. So after that, the people got attention about this Bitcoin, and they find out what is the technology behind this, because Bitcoin no company owns the Bitcoin, right? And no person owns the Bitcoin company, right? It is an automated system. So people go to that particular protocol of the Bitcoin, they play that particular game of a Bitcoin, and they get the Bitcoins, and after that they trade that system. And people were amazed to see this system, that no person is involved in this system, only end users are present, but in the system no human interference is there, right? So many of the companies and developers get mesmerized by this concept, and they thought that okay, so this can be possible if we get this technology of a Bitcoin. So they researched about this technology of a Bitcoin, and they found out this the underlying technology of a Bitcoin is a blockchain. So after that they think that okay, so blockchain is the foundation of this Bitcoin, so we can also use this foundation for other problems that are present, and those are present right now in the world, and we can solve this problem by using this blockchain technology. So many of the developers adapted this blockchain technology. They researched for this thing, and they found that this technology is amazing. So from last 2-3 years, you will find that many of the applications now are built on this blockchain technology, and in the future you will see many more applications that are going to use this technology, because this is the one of the best technology that you can have. So what are the main companies or the main people that are using this thing, and they are pushing this blockchain technology forward? So the first company is the Ethereum, or the network, you can say, that is Ethereum network. So in this course also we are going to use this Ethereum network. So Ethereum networks are blockchain networks, you can say. So Ethereum networks are used to transfer money and store the data. There are many different types of Ethereum networks present in the world right now. So these networks are formed by the nodes, or you can say computers or servers. Okay, and the Ethereum nodes, you can have multiple or many thousands of computers present, right? And each node is a machine running an Ethereum client. So if you have your machine, and if you are running this Ethereum client, then you can also be a part of this Ethereum network. So anyone can run this client on their PC, and they can be a part of this Ethereum network. So, and each node or each PC will contain a full copy of a blockchain, right? So in this course we are also going to see what is actually an Ethereum network, and how to use this Ethereum protocol to build distributed applications, right? So before that, let me tell you what is actually a blockchain versus database thing, right? Many of the people get confused about what is a blockchain actually, right? So if you imagine, blockchain is nothing but a database, right? So our front end that you see right now in the world, those are done in HTML or in HTML5, React or AngularJS. Okay, those are also those things which we can use in blockchain also, because at a front end side there is no difference, right? Only at the back end or at a database level there is a difference, right? So we will see what is the main difference between blockchain and database. So first thing is that blockchain and database are same because they save data. Okay, so only difference is that blockchain saves the data in a blocks, okay, and our regular database like in MySQL or MS SQL store the data in a particular centralized data file. Okay, that is the main difference. Okay, but otherwise there is no difference when it comes to saving data on a blockchain or on a database. After that, the flow to store data is the same, right? In a centralized application also, if you want to pull up some data, that time what you do is that you write a query on your computer and you pass that query to your application server, and then your application server query to your database, and you will get the data back from your application server, right? And the same flow is for the blockchain also, because at a blockchain your computer and your application server are present. Okay, just difference is only at this side. Here instead of database, you will find there is a blockchain, okay, at the back end. So whenever you want to get a data or you want to store a data, that time you do the same flow that you query for your application server, then your application server query for your blockchain database, and then your blockchain database returns the data to the application server, and then to your computer. So the flow is same for your database thing, or database based application, and the blockchain based application, right? But the huge difference is about the money, because as of many of you know, in the centralized database system, or the database that you used nowadays, like MongoDB, MySQL, MSSQL, okay, those database does not cost any money, but blockchain cost you a money to save particular data onto a blockchain, right? So this is the huge difference between your blockchain and your regular database, because to store a particular data on a blockchain you need to pay a money. So this is the main difference that you will find between your regular database systems and in your blockchain systems. Okay, so what is the cost of that money and other things we will see in the next lectures. Okay, also a blockchain store a record for every change ever made to its state, right? So in a normal database, okay, whenever you have some data like users and balance, okay, in the same table you change those things at the same place, right, like their balances. But in a blockchain we save every state of the blockchain, right? If you see this slide, and in this image this is the initial state, okay, and this is the balances for this user, okay. When first transaction happened, okay, just you can see here that the bill sent $10 to Alex, and Jill sent $30 to Andrew, right? So this is the first transaction. So this transaction is separately saved, okay. So this state is different and this state is different, so both these state are saved in the database, in a blockchain. After that, whatever may be the future transaction, those are also going to save in the blockchain as a separate entity. So whenever you want to check, okay, for a particular transaction a hash or a particular transaction data, you can check what is the current state of that system. So this is the beauty of a blockchain, that you will get each and every transaction, and you can check every transaction on a blockchain, right? So what is a block is all about? So in a blockchain, block is all about memory chunks that you can use to store your data and the private keys for that particular blocks, right? So those are only memory chunks, okay, that you can say blocks, okay. So if you look at this example, there is always for any blockchain network, there is always a first block called a zero block or a genesis block, okay. That is a starting point for any blockchain, okay. So that's why it is called a genesis block, and it has a configuration of a how many coins and how many things it will contain in that block, okay. So that configuration is present in that genesis block, okay. And after that, whenever there is some transaction happened on a blockchain, so that time another block is created, okay. And in that block, the previous transactions from the previous block is also saved in that new current block, and the current transaction are also saved in that block, okay. So just like that, for every transaction this process happened again and again and again and again, and all these blocks are connected to each and every one, okay, in a linear manner, right? So that is why it is a block, that is why it is called a blockchain, okay. As I told you that about the genesis block, the first block, okay, right? So we can configure it, okay. So if you want to start your own blockchain network, so that you have to first create this file called genesis.json, and in that file you have to write down some configurations okay, and after that you can use that file to start your blockchain network. In the mainnet also, at some point someone has created this block 0 or genesis block at some point of time, you can say, okay. And you can also develop, or you can also deploy a private blockchain network using this genesis.json in your computer, okay. You does not need to go to your main network to publish your dapps or something that you want to publish every time. You does not need to go to the public server for publishing, right? Because it costs also money. You can also develop your, or you can also deploy your private blockchain in your PC, and you can test and configure your dapps over there also, okay. So this is the beauty of a blockchain, okay. And as I said that the transaction for every transaction, okay, the blocks get added. So who actually mine these blocks, right? So there are some miners, okay, who mines means they validate the blocks, right? And they validate according to the rules or the consensus of a network, okay. So the miners are the people who check that, okay, the data that we got from last transaction is okay according to the consensus of this network, and if that is correct, then they get rewarded for that also, for that validating that transaction. So this is the beauty of the blockchain, Ethereum blockchain, or Bitcoin blockchain, you can say, okay. And the most important thing is on a blockchain is that you can't tamper the data, okay. The blockchain system is hack-proof system. That's why all around the world now people are using this blockchain technology, because you can't tamper the data on a blockchain, right? For example, let's say this is the blockchain system, and say everybody or every miner is working on a block 91, right? Okay, but one of the miners, okay, wants to alter the transaction block 74, right? He wants to alter this block 74 transaction, right? So what he needs to do, he have to make his change and redo all the computations for blocks from 74 to 90, and do block 91, that is 18 blocks, right? So an expensive computing. So if you want to alter the data on a blockchain, you need very high mainframe computers to alter the data on a blockchain. But in the real world right now, it is not possible for any computer in the world to alter the data on Ethereum based blockchain, because it is a already huge network, okay, and you can't afford to alter those data or those transactions on the Ethereum blockchain or any big blockchain network. So this is the main beauty of a blockchain, that it is unhackable, right? So this is all about the blockchain introduction and the history and what is Ethereum network is all about and things. So we will meet in the next lecture. Thanks for watching. Hello everyone. So in this lecture we are going to see Ethereum history and smart contract. So let's get started with the Ethereum history. So as you can find more information on in the internet, so here is the person called Vitalik Buterin in 2013 published a white paper on Ethereum, okay. And after, in the early 2014, Gavin Wood, who described it properly, okay. And after that, in 2015, the Ethereum network or Ethereum blockchain, you can say, launched using crowdfunding, right? So this is the just basic history about the Ethereum blockchain. So what is the main difference between the Bitcoin blockchain and the Ethereum blockchain, right? So what are the features that Ethereum blockchain network provides rather than Bitcoin blockchain or other any cryptocurrency related blockchain networks, right? So these are the some features that you can see in the Ethereum. Okay, so first is a Solidity thing. So the Solidity is a programming language built for the Ethereum, so you can write smart contracts, okay, a smart code you can say, in a Solidity language. Okay, so it is a built-in programming in a Ethereum that you can use to write a code. So this is the first feature you can say in Ethereum. After that, Ethereum is a Turing complete, so it can simulate a computer, and it is said to be the most expressive. Means that Ethereum network acts like the computer. Okay, it runs your code. Okay, it saves your data, it get back to your data, it's secure your code and everything just like that. So it is a Turing complete, you can say. After that, a smart contract. So Ethereum network provides us a smart contract, that is a piece of code running on a blockchain. Means that you can write down a program in a Solidity, you can publish that code on this Ethereum network, and you can interact with that code, and that code is called a smart contracts in the language of Ethereum, right? After that, Ethereum provides us a corruption and tamper-proof system, right? So apps based on the network are formed around the principle of consensus, so making the censorship impossible. And because of the consensus algorithm, there is no problem of the corruption in the system, right? So everyone needs to agree on a particular validation, and then that transaction or that particular data will be saved on that Ethereum network. So that is the beauty of this Ethereum blockchain. After that, it is secure, so with no central point of failure, right? So it is secure, you can say, and all the data on a blockchain is cryptographically signed, so that if there is a problem of hacking happened, okay, if someone gets a piece of a blocks from the blockchain, and if he trying to encrypt or decrypt that block, he will not be able to do that, because the data on a blockchain is stored in a cryptography, so he will only see a number of digits and nothing else, right? So that is the best thing, that it is a secure. After that, immutability. So objects code can never be changed. So when you save your smart contract or some data on a blockchain, so it never gets changed by anyone, or it will never change. So that is the thing. After zero downtime, so your apps never go down, okay, or can never be switched off, because as you know, Ethereum network is a blockchain system. So if one node goes down, or if one node goes switched off, still there are other nodes, those have the same copy of that data that you can get from those nodes also. So this is the best thing also. After that, this is a truly global, so you can say the one computer for the entire planet that never goes off, right? So it is a truly global. After that, the ethers. So this is the main crypto fuel, okay, in which we need to pay for gas, okay, to save the data on Ethereum network. So this is the currency or cryptocurrency for the Ethereum network that we need to pay to save particular data. And after that, there is Ethereum wallet. So it's a gateway to decentralized application on Ethereum blockchain. So it holds the ether for the apps, okay. So these are some features that are superior, and those only present in Ethereum blockchain, okay, and these things are not present in a Bitcoin blockchain. That's why Ethereum blockchain is used all over the world for the development of a blockchain related applications, right? So as we see, smart contract. So what is actually a smart contract is, and what is the property and behavior of the smart contract? So smart contract is an account controlled by a code. Okay, so in the next lectures, when we see that whenever we write down some code, okay, in a Solidity, and when we deploy that code on the Ethereum network, that time we get a particular digits, okay, or address for that particular smart contract, right? So whenever we deploy our smart contract on a network, we get address back, right? So it is a account controlled by code, right? So whenever you want to interact with the smart contract that you have deployed, you need that address, okay? So that is the thing. After that, a smart contract has a properties like it can have the code, it can store your data, it can store your balances, right? So these properties are also presented or is present in a smart contracts. After that, smart contracts can be deployed on a same network with multiple instances, or you can deploy on a multiple networks also. So there are some test networks present on Ethereum, like Ring-Keybit test network, Kovan, Ropsten, and Ethereum, right? On those networks you can publish your smart contracts and communicate with your code, right? After that, when smart contracts deployed on any network, then we get a particular address, as I said just earlier, right? So what are the smart contract languages other than Solidity? So as we know, the Solidity is the main language for the Ethereum based blockchain thing, right? The smart Solidity is a contract oriented high level language whose syntax is similar to your JavaScript, and it is specifically designed for the Ethereum virtual machine, okay? But if you don't know about the Solidity language, and if you don't want to learn the Solidity language, then, and if you are familiar with the other languages like Serpent and Python, then also you can write the code in Python and Serpent, and you can publish your smart contracts and dApps on the Ethereum network. There is no problem, because these languages are also supported by the Solidity Ethereum network. And the upcoming smart contract languages are also coming, like Viper, Lisk, and Chain, okay? Those are upcoming smart contract languages that you can use in the future to write down your smart contracts. After that, what are the Ethereum clients? So as I told earlier, that Ethereum is a network having nodes, right? And we published our smart contract on that nodes, okay? But if you want to communicate with the Ethereum smart contract or that particular node, then you need a clients, okay? So there are multiple clients present right now in the world through which you can communicate with your smart contracts. So the clients are like Go Ethereum, MetaMask, Mist Browser, Parity, Ethereum Plus++, Ganache, and all those are the clients present through which you can communicate with your blockchain. After that, if you want to download the whole main net or the Ethereum blockchain onto your computer, you can use this get program, okay? That will download the whole blockchain data into your PC, and you can be a part of the Ethereum network also. So these are the some clients that you can use, okay? So this is all for this lecture. We will see the next things in the next lecture. Thanks for watching. Hello everyone. So today we are going to look at this topic, Solidity. So this is the programming language in which we are going to develop our smart contracts for Ethereum network. So Solidity is a programming language, as we discussed in our previous lectures, that Solidity is a high level language and it can support almost all things functions, and it is a very expressive language. So before diving into the practicals about smart contract coding or writing the code, we are going to look at some things of Solidity. So let's get started with the Solidity. So as seen in this image, here is the structure of a Solidity program. So it is the same like any Java file structure or JavaScript class. So here is the header file. After that, here is the contract. So it is just like a class in a Java, and the functions and other things is there. So Solidity is not a very different language from you can say Java or from JavaScript. It is similar to them, but the syntax is different a little bit. So it has a similarity, like it has a same class structure like Java or JavaScript. It supports functions, it supports imports, it has a control structure like if else. Also you can use loops like a for loop or a while loop. Also it supports some data types like uint, that is unsigned integer, boolean, array, struct, mappings, addresses. So these are the similarities which you can find in Java also or in JavaScript also. But there is some differences also, just like Solidity doesn't support float values. Okay, so this is the big difference. So you can't use a float value in a Solidity. The people who are developing Solidity language are working towards it. In the future, it might be possible that you can find a support for float values, but right now it doesn't support float values. Okay, also there is a similarity that you can inherit other functions or other contracts. So this is also possible in Solidity. Also there are some special structure like some modifiers or a modifier class that you can use in this Solidity language. So if you are going to write down some function in a Java or a JavaScript, that may look like the same in Solidity. So this is the Solidity function. So how you can write this? So this is a function. Okay, you have to put some function name here. Then this is the public view. So this is a function type, and it returns a string. So this is a return type, you can say. Then you can open the parenthesis here, and this is a returning some value to the caller function. So this is the same just like you do programming in Java or in JavaScript. There is no too much differences. There are some only basic differences or some additional access modifiers present in Solidity, like pure, payable. Okay, so pure keyword no one used. I haven't seen any smart contract that is used pure keyword, but many people use this payable keyword, okay, or this public, private, view and constant keywords. So we will see what is meant by public. So everyone knows that if you define any class or a method or a function as a public, then anyone can call this function. Okay, so in Solidity you can any other smart contract, okay, that also can call the function which is publicly described. Okay, so anyone call this function. After that, there is a private, so only this contract call this function. Okay, so you whenever you write a private keyword before any function or contract, then that contract or a function becomes a private, so only that contract can access those things. After that, there is a view keyword. Okay, so this returns data but doesn't modify contract data. Okay, so as you see in this function, that this function is returning some value, some view. Okay, so you can use a view or a constant, both are the same, but just there is a keyword difference. Just many people use view, or many people can use constant also, but they do the same thing. After that, there is a payable keyword. So payable, uh, uh, we use payable whenever you want to whenever you want to access some ethers, or you want to get ethers to that function. So that time you use your payable keyword. Okay, so we are going to see all those things in our practical sessions, where we are going to use this payable, private and public keywords. Okay, but right now we are just looking these things theoretically. Okay, then after that, how we can deploy our smart contract. So in earlier lectures, as we mentioned, that we can use different tools to deploy our smart contract on different networks, like Remix. Okay, after that, Test RPC, Geth, Ganache. Okay, so there are lots of different networks present. So on them we can deploy our smart contract. But how this smart contract actually compile and runs on the network? So whenever we write down a smart contract, then that smart contract will be compiled through any tool, and then we get two files after compilation of this smart contract. First is your bytecode, and second is ABI. So we get two files from our compiler, bytecode and ABI. And after that, we just deploy our bytecode on our networks. We don't deploy ABI. So what is ABI? So it is application binary interface, which we are going to use, or which people use to communicate with your bytecode, which is deployed on your networks. So whenever JavaScript code or a front end wants to interact with your smart contract, then you have to use that ABI file or ABI code to access the functions or contracts that are present in a bytecode. So what is actually a ABI looks like? So this is the structure of an ABI. So here you can see the structure. It is like a JSON. It's a JSON like structure. So this is a JSON file, you can say, and it contains all the information which you can use to interact with the smart contracts. Without ABI, you cannot communicate with the smart contract. So ABI is very important interface we will need in the future also to communicate with our smart contracts. So this is the ABI. After that, there is one more thing about the smart contract, that whenever you deploy your smart contract on any network, then please test it before deploying on some Ethereum network or on some test network, because whenever you deploy your smart contracts on those networks, you can't change them. That's why it's not possible to change any code or redeploy at the same address. So that is not possible in Ethereum blockchain. So please test your application and do proper programming before deployment. So I will say test properly before deployment. So these are some points that you need to remember uh, before diving into the writing of code. So these are some points, so please take care of these points. And in the next lecture, now we are going to dive into our smart contract things with the remix. So thanks for watching. Hello everyone. So in the today's lecture, we are going to see the remix ID and how we are going to use in the smart contract development and how we can test and run the program on remix ID. So let's get started with the remix ID. So what is actually remix ID is it's a browser based ID in a cloud. Okay, and remix ID is used for smart contract development. It is the best tool you can have to write down your smart contracts before writing down in some other softwares, because remix has some very good features, like it has an integrated debugger, integrated testing environment, it has a static analysis, and it can also deploy your contracts on some testing networks also. And what is the good part of remix is that it also works with the MetaMask or Mist. If you don't know about the MetaMask or Mist, then don't worry about that. In the upcoming lectures, I will show you what is a MetaMask or a Mist. Okay, and if you want to check out the site, you can go to this link, that is a remix.ethereum.org. okay, and there you will find, so let's me go there. So here you can see so this is a remix browser based ID. So here you can find different options where you can create a new project. This is the file explorer where you can open multiple files and you can work on multiple files at the same time. So this is the predefined program that comes up with the remix ID when you open this for the first time. Okay, after that there are compile, run, analysis, testing, debugger and setting tabs also here. Okay, I will show you these tabs and how to use actually this in the upcoming time. Before that, we will see other features like the remix provide you the syntax highlighting also. Okay, as I just mentioned you that you can open multiple files in a remix. After that, if you write a smart contract code into the remix ID, and if you have some error, it can also highlight that error and it can suggest you what to do for that error. Okay, and the best part is that it has a simulated blockchain, so you does not need to set up anything, any programs, any softwares to test out or run these programs, because it has a simulated blockchain. Like you have the JavaScript virtual machine on which you can deploy your smart contracts and test. After that, you have an injected Web3 object, right? If you want to work with the MetaMask or a Mist, you can use this injected Web3 object. And third one is your HTTP RPC local get node. If you want to work with the real Ethereum node that is downloaded on your PC, that time you can use this HTTP RPC protocol. Okay, so these are some features that you can use. And the main thing that Remix provides is the step-by-step debugging features, because many of the times a developer need to debug the code while developing that or writing that code. So debugging is inbuilt feature in the Remix ID. So it highlight your step-by-step code while debugging, Okay, you can view instructions and you can monitor local variables in that debugging state, right? And it will also warn you about the unsafe code warnings, like something like that, because it has an analysis features inbuilt in that. So it shows you warning about gas costs also. Okay, after that, uh, if you using a constant variable or something like that, it also checks that whether it is properly used or not. So the state of the art analysis present in the remix, right? So let's go to this website again, and we will write a small contract in this, and we will run this, and I will show you how to compile and run the code in a remix. Okay, so let's get started. So I don't need this program that is predefined here, so I will just delete this code here. Okay, and I will write down a small example for you guys to understand how the remix how the smart contracts are written. Okay, so first of all, we need to declare your library or the compiled version on which you are going to compile this code. So that need to be declared in the first line. So we will declare that using this pragma solidity upper arrow 0.4.23. so I am going to use a 0.4.23 compiler version, okay, for my test program. Okay, here you can see. So this line will tells the remix or any other Solidity compiler that we are using this version for compilation of our program, so use this version to compile our program. So after this, you need to write down the contract. So as many of the guys is I don't know, but if you go to the internet and if you find some sample smart contract code, that time you can find that you need to write down a contract. So its structure is like JavaScript classes, or you can have Java classes like structure. Okay, so the structure it follows is the same like your JavaScript classes or like Java, right? But the keyword and some syntax is different. Okay, and Solidity is a higher level language, but it does not support all the functionality that the JavaScript has, right? It's had some limitation and it had some problems because it is an evolving language, and that's the problem with this programming language. But for a start, you can write down a better smart contracts in this also. There is no problem in that, right? So just let me start with my contract. So write down the contract, give the name like inbox. Okay, and open your parenthesis, and this is just an example that you can also type in this Remix browser on your computer and test it out that how things work in Remix. So let me define a string here. So string, I'm making it a public, and I'm making this variable as a message. And after that, I need to write down a constructor. So constructor, and I am passing the string initial message public, open your parenthesis or curly braces. Okay, so I have just defined a constructor, and I am passing an argument of a string value called initial message, and I am going to set this initial message to this variable by doing this. So let's message is equal to initial message. So as you know, many of you know, the constructor will be deployed just after this contract has been deployed, and this constructor will be called just only one time when this program runs for the first time. So when this program runs, whatever may be the initial message, that message will be set in this message variable, right? So that's why we have written down this constructor. After that, as we have seen in the Solidity basics, you can define the functions. Okay, so I am writing the functions to set a message. So string new message, I am making it a public, and in the set message, I am whenever I call this function set message, I will set a message variable with this new message variable, or the value that I got from the user, right, in this argument. So just set your new message value here. After that, I am going to write down another function that will give me that whatever the message variable has stored in that, right? So let's write down this function get message, and I am not passing here anything because I am just getting the value from that message variable, right? So I just need to make it public, and whenever you return something or you just need to read the value, okay, that time what you can do is that you can use this view keyword and returns your whatever, maybe the string or uint, whatever you want. So I am returning the string here. My return type is a string type, and just return your value. So return your message here. Okay, so this is the just basic code you can write down for a practice purpose in a remix. And if you now see here that you will find there are some warnings right here. Okay, and this is the compile tab. Here you can select the compiler version that you want. Okay, but I am sticking to the latest one here, and that is this version here. Okay, and if you want to auto compile this program, you can also auto compile this program, or you can just click on this button and start your compilation. So now here you can see my contract inbox right here is in a green color, and this shows me is that my contract don't have an error. Okay, if I make some changes here, like something like this, and you can see it just gives me error because I have clicked on this auto compile, and my compiler just find out that you have an error in this particular line, right? And it is giving me some suggestions also to remove this error here, right? So this is a very fast compilation thing that Remix provides you. So just cancel this. Okay, and again it is showing you that your inbox contract is ready to deploy. Right now we have to run this smart contract. So just go to your run tab, and here you can see a different type of tabs, right? And this is the main screen where you will choose where you want to deploy your smart contract, and what are the things that you are going to do with this, right? So here you can see environment. So as I just mentioned in the slides, that you have three things that it provides you, like JavaScript virtual machine, injected Web3 when you're using MetaMask or similar provider, and Web3 provider whenever you want to work with your local host RPC, right? So just for the testing purpose, I will go with this JavaScript virtual machine. Okay, after that you will find here the accounts, and Remix provide you the 5 accounts with 100 ether each. So these are 5 accounts and they have the balance of 100 ether. Yeah, because as you saw in the previous chapter, I have mentioned that whenever you have to do some operations on a blockchain, you need to pay some ether or a gas, and that's why we need some testing ethers, or we should have account with some ethers, then and then we can run the program. Okay, that's why they have given us these 5 accounts here, and with the hundreds ether each that you can use for your testing. So this is the first account that I'm going to check it out here, and this is the gas limit. Okay, they have provided here. Okay, this is the default gas limit. You can change it if you want. Okay, but I'm leaving it as it is. Okay, and after that there is a value. Okay, if there is a function and that is a payable, right, that time you need to pay some ether to that function. That time you can use this value function value thing here, and you can pay for that particular transaction. Okay, but in this contract I'm not I have not used any payable function. That's why I'm not setting a value here. Okay, so after that, here you can see your inbox contract. So whatever may be the contracts in your program, okay, all the contract list will be shown up to you here, and you can select that particular contract and you can just click and deploy here. Okay, so I will just go here, and it is asking me to pass initial string. So I'm going to pass an initial string like hi, okay, or hello, and I will deploy this. Okay, so here you can see that my contract is now deployed here with that particular memory address, and here you can see that my balance of first account got decreased by some ethers, because it paid some ether to the for the deployment, right? So now I can go here and we will check out this. So here you can see that my contract is deployed and I have 2 function and 1 variable here. Okay, so I am seeing the variable here because whenever you defined any variable as a public, that time this variable acts like a function. So that is the thing in Solidity. So whenever you declare any variable as a public in a Solidity, that time that variable acts like a function. Okay, so if I don't click on any of these things, right, and when we have deployed this contract with this hello string, right? So if you click on this message, you will get the string hello, right? So it just returns you this particular string, whatever may be the saved in this message variable, right? Okay, and if you want to change this, you can go here and we will set the string, a new string here in a set message, like I'm going to say hi everyone. Okay, and I will click on this. Okay, and here you will find, whenever I click on this, here you will get a green sign that your things are correct. Okay, and your function is now set it properly. So this is the thing, and here you can, if you going to open this, then you will find that there are lots of things here, like gas cost and on which account it has been deployed, transaction hash and everything. Okay, and if you got any error, that time it will give you the red symbol here, and whatever may be the problem that you can have here. And if you want to deploy this thing, just click on this debug, and it will take you to this debugger function where you can debug your program step by step, right? So just I have clicked on this set message, and now if I click on this get message, so this is the thing I am getting, hi everyone, because I call this function with this string and I set it up this hi everyone in this new message, and I pass to this message, right? And when I get the value from this message variable in this function by using this get message, I got that string back. And if I click again on this message, I should get this hi everyone, right? So this is how the things works, right? And if you want to if you don't want this variable functions to act like a function, right, then just go and make it private, right, and then recompile your program, go and redeploy this, right, some with message like hello everyone. So just do that thing and just deploy this, and here you'll find only two functions that we have set it up. Okay, so this is how the things works in a remix. Okay, for practice you can write down this program as it is and see how actually remix works. Okay, in the upcoming lectures for our project we are going to use this remix ID very heavily, because whenever you write down a contract, first go to the remix and test it out properly, because you can test all the functions and all the things very clearly in the remix. And if everything goes clearly in the remix, and if there is no problem that you got in a remix, then you can copy those contracts and just put it in the truffle framework, and there you can run those smart contracts without any error, because you have already tested those in the remix. So that is the beauty of the remix. So in the upcoming lectures for the ERC 875, we are going to write down some smart contracts, and that all the functionality of that smart contracts we are going to test in this remix ID. So we will meet in the next lectures. Thanks for watching. Hello everyone. So today we are going to look at some theoretical lecture about what are the types of variable that can be supported by the Solidity, because we need to understand this variable section and the coding structures that has been supported by this Solidity language. So before deep dive into this lecture, I am going to install a visual code into my system, and that software we are going to use for our development purpose. So let's get started and find the visual code. You can go to this Visual Studio Code website here. So website is open. Here you will find the button download for Windows. So whatever may be your operating system, go and download this stable version. So my operating system is a Windows x64 based. So I'm going to install this software into my system. So go and install this stable version. So first let me download this. So now it is downloading here. Okay, so it is now downloaded on my desktop. So go to desktop and do the setup of this visual code. So now it is doing its setup. So just wait for a while. Just click on this launch visual codes and finish it. So it is a free software that you can use as your editor to code the Solidity programs and smart contracts. So now it is opening here. It will just take some time for the first time. Okay, so actually this Visual Studio Code actually made for the Microsoft C hash codes and something like that, but it can support the languages like here you can see a JavaScript, TypeScript, Python, PHP, Azure, Docker and more. So for those language highlighting, you can use their extensions. So now we are going to use this Solidity language in this visual code, so we can go and install their extension from their store. So you can find the store extensions, so click on this extensions here, and here we'll find the top extensions that you can install into this Visual Studio Code editor. Okay, so like Python, C++, and other languages, but we are interested in Solidity, so find the extension for Solidity. So here is the first Solidity version that you can install. Just click on this install button. Now here you can see it is showing me that it is installing into my Visual Studio Code editor. So actually if you even doesn't install this extension into your this Visual Studio Code, then there is no problem actually. But why I am actually installing this software, because it highlights the syntax, the correct syntax for the Solidity. Just like here you can see that the syntax highlighting snippets, okay, compilation of the current contract. So this can be possible with this Solidity extension here. So this will help you to understand the highlighting of the Solidity program, their contracts and other things. So if you wish to install this, you can go and install this extension into your Visual Studio Code, or you can use any other editor for this. It sometimes takes some time because it's a little bit huge extension. That is why it is taking some time, I think so. Okay, but it is taking okay. So now it is done with the extension. So just close this. Okay, so as we discussed earlier in this thing, that we are going to look at the types of variables supported by this Solidity language. So what we can do is that we can go to the file, new file. Just I am typing that. I am not writing down any Solidity code here. Okay, I am just showing you what are the types supported by this Solidity language. So the strings, as you know, the variable type supported by Solidity. Let me zoom this. So first is a string. Everyone knows that string, like hi, hello. So these are the string which is supported by Java and other programming languages. So Solidity also supports a string type of variables. And after that, it also supports a boolean like true and false values. After that, it also supports integer, like as we know, 0, minus 100 and 100 and plus value like 100. It has a new you can say variable that is very important and that is widely used in Solidity, that is called unsigned integer, that is uint. This is unsigned integer. So it has only positive values, it supports only positive values, means that you have only 0 and 100, but you cannot have minus 100 here values, only positive value it supports, positive values it supports. Okay, so after that, float is not supported by the Solidity. Okay, and there is also a new variable called address, so which gives you the address of the owners and senders and everything in the format like 0x846536788F6, something like this. Okay, so these are the some variable types that it's supported by the Solidity language. Okay, so if we go into the deep about this, like integer and uint, their ranges, so let me give you some details about those. Okay, so what is the main difference between this integer and uinteger range? So many of the people you know that integer starts with integer value like 8, after that integer 16 is there, after that integer 32 is there, and so on, and last value is the integer 256. Okay, and as you know, integer 8 only supports up to minus 128 to upper value is 127, and integer 16 supports from minus 32,768 to upper value plus 32,768. Okay, so just like that, the number goes on increasing at both the end, at the negative end also and at the positive end also. Okay, like into 56, integer 256 supports really big number, big negative number, you can say negative number, and at a plus side, upper side, it is a really big positive number. So this is the main difference between the integer 8 and integer 256, that their range is different. Okay, so actually many of you use only integer, you never use like integer 8 and integer 256. So integer is as same like integer 256, both are the same. So in many examples in Solidity also you can find integer or integer 256. Okay, so both are the same, there is no difference between this. Okay, but as we discussed that there is a uint, that is unsigned integer. Okay, that is also supported by the Solidity. So it has also, it starts with uint 8 its lower value is 0 always, and upper value is 255, and uint 16, its lower value is also 0 and upper value is 65,535. okay, and just like the same way in integer, it supports uint 256 and its initial value is also 0, but positive value is really big positive number. So uint only supports a positive number, it doesn't support any negative number. So in Solidity many of the people uses this uint 256. So in our program also we are going to use this uint 256, or you can use uint sorry, I have some spelling mistake here. So uint, and so uint, and that is same as uint 256. So it is also the same, that is u integer is equal to u integer 256. So you can use any of these things. Okay, so as we have seen that in this lecture that it supports many different types of variable like string, boolean, integer, uint, and addresses. Okay, and we have gone some in details for the integer and what is the uint. Okay, so it is just a variable supporting a video, actually what the variable it supports. So in the next lecture we are going to see another things that it's supported by the Solidity, like mappings and struct, and what is the message variable. Okay, so that we are going to see in the next lecture. Thanks for watching. Hello everyone. So today we are continuing our last lecture. In last lecture we have seen that what are the variable types supported by Solidity. So in this section I am going to show you what are the structures and what are the new types of things that is supported by this Solidity. So first I will show you the message variable. Okay, so you can say it is a global variable. So what is a message variable in a Solidity is that it has the address of the contract. Okay, you can have this message variable accessible wherever you wanted in the code. So this is a global variable by default, so you can call this message variable in any function or in any constructor. Okay, so this gives you the address of the owner who is either sending the money or sending the ether, or the address of the contract. So you will see this message variable many of the times in Solidity language. So always remember that this variable is a global variable and that can be accessed anywhere in the program. So this is the by default variable that has been given by the Solidity to us that we can use in our programs. So another things that Solidity gave us is a mapping. So mapping is a collection of key value pairs. It is just a collection of key value pairs. Okay, all the keys in a mappings must have of the same type. Okay, just like for example mapping. So this is the syntax for mapping: string, okay, or mapping integer and boolean. So it is a collection of key value pairs. Okay, many of people know that this is also used in other languages, but their name is or syntax is different. Okay, so in Java, like you can say it is a hash. Okay, Python you can call it as a dictionaries. Okay, something like that. Okay, but in Solidity we are going to call it as a mapping. Okay, so it is a collection of key value pairs, and as I said, all keys must be of the same time and all values must be of the same time. Okay, so this is the mapping. And if you want to use a collection of a key value pairs that has a different types of values or keys, then you can go for the struct. Okay, so it is a collection of key value pairs that can have different types. Okay, for example, let me give you an example. Okay, first write down it's also a collection of key value pair but of different types. So for example, you can have a struct car, and in that you can have a string make string model and event value. So as you can see here that it is a structure of a different key value pairs. So here you can use a string, okay, and you can also use event or boolean or any other variable type. Okay, so it will give you the different types of structure that you can use as a variable in your program. So this is another things that is given by this Solidity. So in our program also we are going to use this struct thing and the mappings thing and message also. So this is it for this lecture. So we are going to see the program in the next lecture. Thanks for watching.
Hello everyone. So in the today's lecture we are going to install the essential softwares for our smart contract development and for our project. Okay, first of all we need to install the Node.js. Okay, so you can go to the google.com and find Node.js in that google.com. Go to this website, that is nodejs.org, and here you will find different version for different operating systems. Okay, but I have a Windows 10 operating system which is a 64-bit, and for that I am not going to go with the current version, that is because it's a current and unstable version right now. So they have recommended 8.12.0 version, that is the latest one, and this is the stable version that you can download for your software. Okay, so just click on this and it will get downloaded here, and after that click on this and do the setup. Okay, so it is now doing the setup here. It will take some time depending on your PC's hardware configuration. Okay, so it is, yeah. So wait for some time to complete this setup. Okay, and after the setup has been done, okay, just click on this finish, and you can now then go to your command prompt and open that command prompt in administrator mode, just like this, run as administrator, and you can check the node version by using this command, that is node minus or -v. Okay, so this is the version that I have installed here. After that, I need to install framework, and this is the website. Just click on that and go here, and here you will find a ganache. So just click on this GitHub repo here, so there are two versions. One is a command line version and second is the desktop version that has an UI. Okay, so this is the UI version, and another is the CLI version. Okay, you can go here and click on this ganache. Okay, and here you'll find the UI version, and I'm going to install the desktop version for this. So just click on this Windows, download the Windows button here. So it will get downloaded. So it is a big software and it will take some time. So okay, so it is now downloading. Now it is downloaded. Okay, so now just go here and click here, that is need another OS download, and here you will find this version here, different versions, but I am going to go with this version, that is the exe file for Windows. So now it will get downloaded here. So wait for some seconds to download it. Okay, and click on this to do the setup here. And just install this. And click on this finish button. So now my ganache will run automatically after this. So now here it is open. So just disable this, analytics enabled. So disable this and click on this continue, and this is the graphical version of the ganache. And here you will find some accounts with the balance of Ether. Okay, There are blocks, transaction here you can see. So this is the just test local test network which we will use for our testing of the smart contracts. Okay, so you can go and download all these softwares from the net as per this video and install it before we can start with the smart contracts coding. So we will meet in the next lecture. Thanks for watching. Welcome to this lecture. So in this lecture what we are going to do is that we are going to write down the smart contract code into our project. Okay, and for that what we can do is that we can go to our truffle created folder, and in the contracts folder we can create a file called mortgage.sl. so this is a Solidity file and in which we are going to write down the smart contract code for our mortgage processing thing. So this file contain all the necessary code to process the mortgage terms and everything. Okay, so if you don't know about too much about the mortgage thing, so then you can go to this mortgagecalculator.org website, and here you can find the different terms for the mortgage, right? Like what is the home value, what is the down payment, and what the loan amount and interest rate, and how much years of tenure you have to pay that loan amount, what is the monthly payment and everything. So you can go to this website and you can do the calculation, and the same thing we are going to implement in this project. And for the formulas for the mortgage calculator, you can go to this wiki.how, and here you'll find all the stuff relating the formulas. Okay, and so let's get started with our mortgage.solidity file. So first of all, what I need to do is that I need to declare the compiler for our smart contract, and for that I need to write down pragma solidity and the version. So just declare the version, whatever may be the newer ones. So 23 is the latest and stable compiler version for the Solidity. Okay, so this line will tell the Solidity compiler that using which version we are going to compile this code. All right, after that I need to write down the contract. So contract mortgage, so write down your, so this is just like a class. So whenever you write down a contract, so it look like a class in Java or in JavaScript. So just there is a change of a keyword, that is a contract here, right? And in that, first of all, so here is an error actually. So this error is of my editor. So just I need to change to LF here. Okay, and my error will gone, and it's gone now. So first of all, what I need to do is that I need to declare a constructor. So that constructor will deploy our contract on a blockchain, and then we will initialize with the loan status. First of all, we will initialize our loan status with the initiated thing for the testing purpose, and we will give the loan applicant's balance to 1 million, right? So in the constructor we are going to initialize the balances of the loan applicant will be 1 million. After that we are going to bind the owner's address, that is the message.sender address, to the loan applicant, and other thing we will write down that in that constructor.
Also note that since the Solidity does not support float or double at this point, so we are going to store the actual value and we will multiply by 100 in the contract, and whenever we want to retrieve those values, then we will divide the contract by 100, so that will be shown correct balance on the UI, right? So first of all, start with our constructor. So constructor, and in that public, so this is the syntax for the constructor here. And as I just mentioned earlier, that we need to set the message.sender address to the loan applicant. So create a loan applicant variable, and in that set the message.sender value here. So message.sender. Okay, so this line will set the message.sender value to this loan applicant. Okay, and after that, what I need to do is that I need to write down the loan status, and I will set that to the status initiated, as I earlier mentioned, status initiated. And for the testing purpose, I need to set the balance for the loan applicant to 1 million. So write down balances dot message.sender to or higher, you can also set. So you can disburse many things, but I am going to use 10 million here. After that, so these are the things that we are going to declare here. So first of all, I need the address of the loan applicant, and for that I am going to use the address keyword, and in that loan applicant. Okay, and I am also going to use the events for this smart contract. Okay, so this error here is coming because these things we need to mention somewhere in the code. So I will declare those things after some time, so that error will be gone. Okay, so just now just write down the necessary things for our smart contract. So I also need the events. So event will publicize the action to the external listeners, and for that I'm going to use the event keyword. So write down event, and in that line release, line released, and in that I am going to pass the address of the owner using underscore or whatever variable you want to use. After that, I also need the event power line transferred, and the address of the owner here, event loan status, and in that status here. So these are the events I have mentioned here. Okay, and after that I need some statuses here, right, to check whether what is the status of my loan. Okay, like it is submitted, approved or rejected, something like that. And for that I am going to use the numbers here, okay, that I can compare in the next code. So I need to declare the integer, and in that use the constant, so nobody can change the values of this variable. So status initiated, and I will assign the value of 0 here. So whatever may be the value you can use here. Okay, constant so integer constant, so I can copy and paste these things here. So just paste this, make it 2, and status approved here. Again copy and paste these things and make it 3, and check the status here with the rejected here, right? So these are the statuses here. After that what I need to do is that I need to declare the structures, right, for the property against which user wants to loan. Okay, so here I need to declare different data types for different values, like property details I need to use the struct. Okay, and loan terms, that for that also I am going to use the struct. Okay, and after that for the monthly payment I am going to use struct. For the loan also I am going to use struct. So as in the earlier lecture you have get the little bit of idea about the struct, right? So for that I am going to use the struct here, and before writing down the formulas and other stuff I need to declare all those struct so that I can use in the later programming code, right? So first of all I need to write down the struct for my property details, to store my property details, right? So for that just write down the struct property, and so in that I'm going to store the property details. So I will store the address of the property in bytes, so bytes 32, address of property. After that I am going to use the purchase price for that particular property, so I am going to use uint here, I can use uint32 also. So purchase price, and after that I need the address of the owner for that particular property. So address of the owner. So these are the basic details that I want to use for my smart contract and store their values here, right? So this is the one struct, right? After that I need to store the loan terms, like the interest, loan amount, annual tax, annual insurance, everything, loan term, right? For that I'm also going to use the struct. So struct loan terms, and in that I'm going to use uint32, that is term, okay, to store the term of the loan. After that uint32 interest, and I also need to store the loan amount. So uint32 loan amount, uint32 annual tax. So these are the just variable that I need in the latter program. So uint for annual insurance, okay. So this is the struct type for my loan term, and this struct is for property details. Just I need to mention this. So property details, okay. After that what I need to do is that also I need to store the monthly payment structure, right? Like what is the monthly tax, what is the monthly insurance, right? So for that I need another struct here. So use struct monthly payment, and in that I need to use uint32, right? So payment, so first variable is this payment installment. After that uint32 for taxes, and uint32 for my insurance, okay. So this will store the structure for my monthly payment, okay. And after that I also need to write down the structure for my loan contract. So struct loan, so this will store my loan contract details here. So like loan terms, so make the variable for that. combination of struct, like nested struct you can say, because I am using the variable for this struct that I have already declared above, right? So this loan terms is the struct here. Okay, so I am making the variable of this struct here in this loan, and after that I also need the property struct. So property make the variable for this, and after that monthly payment, and you can use the monthly payment here. Okay, and I also need, I just forgot that I also need the actors account. Okay, so for that I need to declare another struct. Okay, that is actors account means the mortgage holder, right? So for that I need to declare another struct here. So struct actor accounts, and in that I need the address of the mortgage holder. So mortgage holder, address of the insurer, and address of internal revenue system, so IRS. Okay, and now I am going to make the variable for this struct. So actors accounts here, and I need another variable to just save the status. So integer status. So this status will contain the values of these variables like approved, rejected, submitted. Okay, so now we have done with our structs. Okay, like for property details, loan terms, okay, monthly payment, actors account, and for the loan terms, right? And now what I need to do is that I need to call these things here also, because I need to use them separately also. I have already made some things here in this struct. Okay, so whenever I want to use this struct, I can use this struct. Whenever I want to use a single functionality of a particular struct, then I need to call that struct separately, and for that I need to declare the variable for the struct outside of this struct, right? So I can use them individually. So for the loan, so for this struct I am going to make a loan variable, so I can use this struct separately, and just like that for the loan terms I can copy these things from here and I can paste it here. So this will allow me to do this separately, right? And in the above lines we have still error of the balances, so I need to declare the mappings for the balance. So we have already learned about the mappings. So mappings is nothing but just an associate array or hash map addresses. Okay, and in this mapping I'm going to use this for mapping of actors in the mortgage contract with their balances, and for that I'm going to use the mappings. So you can use the mappings here. So mappings, in that addresses event to 56 public balances, right? And here you will find that my error is gone, right? So in this lecture, this is it. We saw and implemented the structures and constructors for our mortgage smart contract, right? So in the next lecture, what we are going to do is that we are going to implement some more functions like modifiers. We will write down the functions for deposit, get balances, and other stuff. Okay, so we will meet in the next lecture. Thanks for watching. Welcome to this lecture. So in the last lecture we have written down the structure and struct for all the things that we need for our project. Okay, so in this lecture we are going to write down the functions. Okay, so before that I just need to check that my mortgage contract should be called by only the contract owner. Nobody else will able to call my contract. Okay, so here I can use the modifier thing, right, to check the bank only, or the whatever may be the entity that is owner of this contract can able to execute this contract functionality. Nobody else will do. So for that I am going to use the modifier, because I need to use this modifier in my project. So for that I am going to use the bank only modifier. So in that I just need to check that if message dot sender is not equal to loan dot actors account, mortgage holder. So this should not be so the message sender value should not be equal to the mortgage holder's address in any case, right? So means that the only bank or the owners of this address can run this contract, right? And if anybody tries to run the functions, then it will get an error here. So I am just throwing him out here, and I need to use this underscore. Okay, so this is the syntax for modifier. So modifier we can use in any places. So after that I need to write down the main functionality for my smart contract, that is for like deposition and get balances. So first of all I will start with the deposit function. So what will this deposit function will do is that this deposit will make into an actors account, and this will return the balance of the user after the deposit is made, right? So for that I need to write down the function, and function deposit, and I need to pass the address of the receiver who is receiving the amount and how much amount it is receiving. So these two parameters I need to pass, and I need to write down the public method which will return the integer, that is uint 56, and in that what I am going to check is that balance of the sender should always be the greater amount, means the value he is passing should be greater than its balance, right? Then and then he can only send the money. Like if he has like balance of $1,000 and he's trying to deposit a $1,500, then that will be an error, and this is not a correct way. So that condition I need to check using if condition, and for that I need to use if, and I need to check the balances here first. So balances for the message.sender. So whoever may be this sending entity, his amount should always be lower than his balance, right? Then and then he will able to deposit the amount, right? So return this, and in that what I need to do is that I need to minus the amount that a user wants to send to the receiver. So first of all I need to minus that particular amount from the message.sender's balance, okay, and then that amount should be added to the receiver's account. So for that I need to use the balances message.sender amount. So I'm subtracting the amount from the message.sender's account, and I need to deposit it into the receivers. So balances for the receiver, I need to plus this amount here, and so here is a spelling mistake, so just make it clear. And here I need to return the balance for the receiver. So return the balances for receiver, because after the deposition of this balance amount from the message.sender, I need to return this to the calling function, so it will get the idea that how much amount is deposited and in which account. So receiver here, so just okay. So this is the function for deposit. After that what I need to do is that I need to get the balances for receiver whenever anybody wants to call the or wanted the balance of the receiver. So for that I need to write down the function. So function get balance, and it will return the address of the receiver. Make it public constant, or you can use view also instead of constant, and this will return an event, right? Just return your balances for the receiver. Okay, so this is the function for the receiver to get the balance. So whenever user call this get balance function, he will get or she will get the balance for that particular receiver, right? Okay. After that, I also need to check that whether the mortgage payment is a complete for that particular property or not. If it is a complete, then I need to release that property line to that homeowner or homeowner, right? Okay, and so for that I need to check whether the user's mortgage is paid off or not, right? So for that I need to write down another function for that. So I'm going to call this check mortgage payoff, and in that I need to check whether the mortgage is paid off or not. So for that I need to check all the criteria, like its loan balance for that particular mortgage holder, right? After that I need to check the insurer, and I need to check the IRS for that. Okay, with the loaned amount, monthly payment, what the actor has been paid, right? So for that I need to write down the if condition, and in that I need to check the balances dot loan dot actors accounts, right? So actor accounts, and in that actors account I need to check the mortgage holder, right, for that particular address, and I need to check with loan amount that is paid monthly. Okay, into pi dot into 12 for the year. Okay, and the loan term, so in that term, right? And I also need to check using AND condition that the same thing, but just need to change something. So here I will copy this from here, and I will paste it here, and I just need to check for the taxes, right? For insurer here, and here I need to check with the tax. and all other stuff will be the same. And the same thing for my IRS. So term insurance and IRS. So IRS is the internal revenue services that has been present in the mortgage space. So if you don't know about this, all this stuff like who is insurer, IRS and other stuff, you can Google these terms in the mortgage space, and you will get the idea of what is the IRS and what is their work in this mortgage space and what is the insurer and other stuff. So you can Google it for more information, right? So now I have this my if condition here, and if my mortgage payment is completed, okay, if this if condition fulfilled successfully, then what I need to do is that I need to release the property line to the homeowner, right? So for that I need to access this owner first from the property dot owner, and I need to assign the address of the loan applicant now to that loan property owner address. So loan applicant now becomes the owner, and just emit here line released. Okay, so this will release this thing. So just loan dot property dot owner, right? So this is the error that I am getting. So I just need to declare this line released thing. So I will declare this thing, okay, after some time, but I need to check this check mortgage payoff thing in the deposit also, because whenever user going to deposit some amount, I need to check first of all that whether its mortgage is already paid off or not. If it is not paid off, then I will this contract will deduct the amount from his balance and add that to the receiver, okay, if it is not. And if it is paid off, then it will just return the balance. So I just need to copy this thing from here and paste it here to check this thing, okay. So now we have done with our mortgage payoff functionality. So now what I need to do is that I need to add the loan details into the contract. So user will add the loan details here. So these are just gonna be the placeholder that will add the loan details into the contract, and another function that will return all the loan details from the contract, okay. So for that, what I need to do is that I need to write down the code for adding the loan details. So I will add the function. So submit the loan details, submit loan, and I need to declare some variable first here. So just declare the variables. So bytes 32, So these are all things that I will need for my program. So just address of property. After what I need to submit is that the purchase price. So what is the purchase price for that property? So event 32. So purchase price. I also need the term. So event 32 term for the loan payment. So how much years he is eligible to pay the loan, like 20 years, 30 years, something like that. After that, the loan interest. So how much interest he needs to pay. So for that I need to use another variable, that is u in 32. Interest, and sorry, I just here made a semicolon, so they are one after another. After total loan amount, so I'm going to copy this, paste loan amount. After that, what I need, that is the annual tax. Annual insurance amount. So annual insurance, right? After that, monthly PI. So these are just the declaration of the variables that we need here. So monthly tax, monthly insurance, the address of the insurer, and address of the IRS. Okay, and so this is just a declaration of the variables. Now I need to write down the public function here. So just public, and in that I need to map the variables value that a user entered, okay, into my smart contract. Okay, so my smart contract variable, which I can access using loan struct, right? And in that property, so first of all I need to set the address of a property. So address of a property, and here I just need to set the address of the property. After that, the loan dot purchase price. So I'm going to just set this value into my structure that will hold my values for that particular account or address. So loan dot property dot purchase price underscore purchase price. After that, the term, the loan dot term dot loan terms, and in that I need to find the term and just set this here, the term. So loan dot interest, so loan terms dot interest, after that loan amount, I need to map with the loan amount. After that, the annual tax, loan dot loan term, annual tax, and this is the annual tax here. Okay, after that I need to set the loan dot loan terms dot annual insurance, with the annual insurance. So actually here is the spelling mistake here. So annual insurance that variable I am going to use here. Okay, so I am done with the engine insurance. Now I need to check with monthly PI. So loan dot monthly payment dot PI is equal to underscore monthly PI. After that, so all these things I am getting from this struct, right? So like PI, tax and insurance is a part of monthly payment, so from that I am calling this, right, using the main struct, that is our loan struct. So loan dot monthly payment dot tax, so monthly tax, sorry, here is the P is I think uppercase, yes. After that loan monthly insurance, sorry, loan dot monthly payment dot my insurance here, and the same way I just need to check the loan.actors account, accounts dot mortgage holder, after that loan dot actors account dot insurer, which will map to the insurer here, right? After that, for the same case for the IRS, so actors account dot IRS is equal to IRS, and just loan dot status and make it status submitted, right? So whenever user calls this function, its status will be changed to the status submitted. So this is the code for submit loan. Okay, and the same thing we can use for our get loan details, right? So for that, what I need to do is that I need to write down another function here. So function get loan data, and this will return us the loan data for that particular loan. So here I again need to declare the variables. So just I'm going to copy and paste this variables from here, and I'm just going to paste it here because these things the same way I just need here. Okay, but just I need to add the status here. So int status, and just I need to map things in the reverse order because I am now getting the details from the smart contract. So in the above function I am adding the things from my fields to the smart contract variables. Now I am fetching the values from my smart contract variables. So I just need to reverse this order here, and I need to map this to the this temporary variables here. So for that, just write down the thing that is address of a property is equal to loan dot property dot address of a property, right? The same way, but just I need to reverse this order. So after that, purchase price, loan dot property dot purchase price here. After that, term, so term, loan dot loan terms dot term, after that, interest is equal to loan dot loan terms dot interest. After loan amount, loan dot loan terms dot loan amount, annual tax is loan dot loan terms so after that, annual insurance I need to fetch. So loan dot loan terms dot annual insurance. After that, the monthly PI, from loan dot monthly payment dot PI. After that, monthly tax, so loan dot monthly payment dot tax. After that, monthly insurance, dot monthly payment dot insurance here. And the last thing I can do is that I can set the status. I don't need the insurer here, so an IRS. Okay, so I just need this above values, so I just need to set the status here, check the status. So status is equal to whatever may be the status it will get, status, right? So now we have done with last thing we need to write down is that we need to write down the function for approve or reject loan. So for that, just I need to write down the function here. So function approve reject loan, status, and this function only be called by bank only, so I'm using this bank only modifier. Let me check the bank only. Yeah, so in this I just need to set the status. So loan dot status is equal to status, and if so here I am just checking that if the status is approved, okay, then the loan line will be transferred to the property owner, right? So here the loan property owner is the message sender, right? So loan dot property dot owner, I am setting its value to message dot sender, and if it is approved, then just emit the lined transferred event. And just transfer this dot to owner here, okay, and if it is rejected, means else part, set the status. So just emit loan status here using loan dot status. So here are some spelling mistakes, I think, so just let me clear all this, sorry. Sorry, there are some spelling mistakes here. Okay, so now monthly PI, so here again H and H, so just copy here, paste, add the H here, and this error is of event. So just copy this. So now I need to check with the error because there are some typos are there, and I am just checking all these things. So let me check with my parenthesis here. So this is the correct parenthesis here. So here the loan terms. So this is my smart contract. I am getting some error. Let me check with the term here. So term, so it is actually a term, so spelling mistakes are there some. So when you write down programs, some typos happened many of the times. So here my error is gone now. So I need to check this also, terms loan amount. So I think that is my editor's error, I think so. So if I close this, I open, so no error will be there. So sometimes it is giving me error. So let me check this. So now I have resolved that error. That is also a spelling mistake. So now we have done with our smart contract code. Okay, so in the next lecture we will continue with our project, and so we will meet in the next lecture. Thanks for watching. Welcome to this lecture. So in this lecture what we are going to do is that we are going to create a truffle file structure that we will use in the next lecture for our contract creation, and we are going to write down the code in that files. So for that we need to create the folder in your hard drive, and after that just open the terminal, okay, and write down the command that truffle init, and press enter. So it will give you the structure of truffle, right? And here you will find that different types of folders has been created automatically. So this is the just blank project, and we just need to install some scripts in this folder. So we will start with truffle.js first. So just open your truffle.js file, and here you'll find that all the code is commented. So for that code we need to go to the truffle website here, and in the truffle website you go to the documentation of truffle, and in that documentation go to the creating a project, and in the last part you will find a configuration file. So this configuration file will need to deploy our project on our local network using Ganache. So copy this code here and paste it in this module.exports, right? So here you can see that the host is 127.0.0.1, means this is the local host, and our port is 8545, which is also a port of Ganache. So we can connect to this our private a local network using this script. Okay, so if you want to connect to other testing network like Rinkiby or Robston, then you can go to their documentation website, and they will find different types of scripts that you need to copy and paste it there, right? After that, what we need is that we need a package.json file. So for that, so just create a file that is package.json. Okay, and here what I need to do is that I need to copy the dependencies that I have already copied and pasted it into Notepad, and now I'm copying this into my project. So these have all the dependencies that my project requires. So this will download all the node modules from the internet that is required for our project. So just open the terminal here and just install npm command, npm install, press enter, and this will download the data from the internet. So this will take some time because this is a very huge folder having around 300 MB of node data. So just give some time to download it, and it also depends on your internet speed, that at which speed it will be get downloaded. So now it is downloading and installing the things. So after the installation of this, we will going to write down the smart contract code in the next lecture, but we will wait for these node modules to be completed first. So wait for some time and have the patience. Now it is installing. So it will also take some time to unpack the things. So now it is downloaded and installed successfully. So in the next lecture we will start with our smart contract code. So for this lecture, thanks for watching.
That the Mocha or this truffle actually supports. Okay, so for that I need to first explain you some of the functions that we are going to write down in our project for the testing things, right? So first thing is that what are the functions that are supported by this truffle testing framework, right? So let me write down the functions and their purpose here. Okay, so we are going to use IT, that is it, and its purpose is to run a test and make an assertions. Okay, after that we are going to use describe, which groups its statements. So whenever you have many its statements in your test cases, okay, that time you can use, and you have to use this describe function. So it groups together all the it function. And third one is a before each. Okay, so it executes some of the general setup code. So execute some general needed or setup code, you can say. Okay, so these are the functions that we are going to use in this truffle testing framework. Okay, so it is used to run a test. So whenever you have to check some contract function, that time you have to use this it function and write down the testing code in that it function, and then it sorry, I think here is the ms dog, and after that it make an assertions on that. So we need to describe this it function in the test. After that, if there are too many it functions in your test, that time you have to use this describe function. So it just groups together all the it functions, and before each function is used when you have some code that need to be initialized or need to be set up before each test. That time you can use this before each function. Okay, so now I am going to show you some just basic example that how we are going to write down a test. Okay, that is not a real test. This is just an example that I am going to show you, so you will get an idea how we are going to write down the real test for this smart contract. So let me enter here. So here now I am going to write down example class. Okay, so if I mentioned a class, okay, class like a car, and in that I want to test a park function, okay, which returns me stopped, and another there is a drive function that I also wanted to test, and it returns me vroom. Okay, so now I wanted to this is my class and these are my functions, and I wanted to test these functions whether or not
they are returning the same result that I wanted or that I mentioned here, or they are making some another result. Okay, so what in the testing, what we actually check is that the result that we wanted or that we have mentioned and the result which is generated by the code is the same or not. So that is the assertions that we need to make in the test, right? So this is just a class. Now I have to write down test cases for this. Okay, so for that I am going to use this describe function. So describe and in describe function I have to mention two parameters. Okay, first is the comment that will describe you okay, which thing is executed, and so it will just for the reporting part. Okay, so whatever you may want to add up here, you can add up. Okay, so for example I can add up like a car or car test, something like that. Okay, so if I put this like a car test, then I can say here like that. Okay, and after that I need to give the second parameter, and that is the arrow parameter that I am going to give here. Okay, so that is the syntax for this is like this. Okay, and after that I need to mention the test code in this. Okay, so as we have mentioned earlier that we always mention the testing code in it function. So I need to write down it function here. So it, and it also takes a two parameter. Okay, first is the comment parameter. You can put anything here. Okay, so I say like car park, or can I park. Okay, and after that also I need to put the arrow parameter here. Okay, and in that I need to mention the code. Okay, so for that I can assert here. Okay, so assert equal car.park, and I am checking with this value, that is stopped. Okay, so what is I am checking here is that I am checking that whether the code generated thing or the result is the same that I wanted in this lecture, or I wanted in this assert is the same or not, right? So if I run this code in a Mocha or in this Truffle, okay, but we are not running this code right now. Okay, this is just an example. So I think if I run this code in Mocha or in Truffle, so it will give me or it should return me this top stage, right? And if it is it gives me some other results, okay, in this parameter, and this thing is different. Okay, then that test you can say it is a fail one. Okay, so it fails because the code generated thing or the result is different than what you are expected here, right? So also before this I need to call this class, because class is outside of this describe and it function. So I need to make a variable for this, that the initialization of the class, right? So new car. Okay, so this is just an example. It is giving me an error, something like that, but I am just showing you how we actually write the code for the tests, right? So it is not a real code. Okay, after that I also can write down the code for the same, that is for the room function. So I'm just going to copy this and paste it here. Okay, and I'm checking that room. Okay, and okay, so this is the way by which, okay, let me change this also. I need to change this drive. So okay, so in this thing we always assert that whatever may be the result should be equal or not, and upon that our test is either pass or fails, right? So we have seen these two things in this in this file. Now I am going to show this before each function. Okay, so when to use this before each function. So whenever you have a code that need to be initialized, or that you need to run before each statement, okay, that you can put in that before each statement. Okay, so for that you can write the code like this. Okay, so before each I am passing this arrow parameter here, and in that I can say something like that, log dot e or something like that, and logs. Okay, so how actually this before each function runs, right? So whenever you run this file in the truffle, okay, so whenever you run the test one by one, so before each test, okay, this file or this log will be run before each test. Okay, like that this will run, okay, first, after that this will run, and again this will run, and after that this will run. So this is the flow of this before each statement. Okay, so in our example here you can see that we need always this initialization of the car, so that we can use here. Okay, so we can remove this and put this here, and we can remove this and put it here. So whenever you run this test, so what this before each do is that it always initialize this car class before each test case or each statement, you can say. Okay, so another thing that you have to think is that if you are going to run this code in a truffle, it will give you an error of this car variable here. Okay, because it is not defined in this function or in this described, so it is not accessible by this car variable. Okay, because it is outside of the scope, right? So for that what we can use, that we can remove this constant. Okay, this is the constant. So when we use a constant variable, so whenever there is a no value change for a particular variable, that time we can use a constant. Okay, but if the value of the car it change for each iterations, okay, so that time you have to use a let keyword. So you can use let car keyword. So here each time the value of the car changes, and you can use that value by using this let variable car. Okay, so this is how actually we write down these functions here. Okay, so okay, sorry, here is the problem. Okay, so this is how we actually write down the test and things for this. Okay, so by this way we are going to test the code or the smart contracts using the test cases that we are going to write down in the next lecture. I should have to mention here that In the test cases, we also going to see this functionality called async and await. Okay, so it syncs the things. Okay, its name is async. Okay, but it syncs the proper things. It syncs the proper code for your test cases and wait for the particular things to be happened, and after that it will run the next code. So this is also the things that we are going to see in our next lecture. So in the next lecture we are going to write down the real test cases for this gradient token. Okay, so we will meet in the next lecture. Thanks for watching. Welcome to this lecture. So in this lecture we are going to write down the test cases for our project. So in this project I am going to write down only a single test case for our project, and that is for the deposition of the amount. If you wanted to write down more test cases, you can do some research and development on this, and you can write down the test cases for yourself also. So for example, example, I am going to write down one test case, and for that I need to go to this test folder, and I need to create a file that is called deposit.js. So all the test cases we will write in the JavaScript. Okay, so if you are familiar with the JavaScript, then you can easily write down the test cases. So we will start with the file import. So first of all I need to write down the variable for this, that is variable mortgage, and in that I need to write down the artifacts which will require my file, that is my contract, that is mortgage.sol. After that I need to write down the contract. So in that contract I need to pass the two parameters. First is your string, like whatever you want to write. So I'm going to write down the mortgage basic test, and in that I need to pass on the function, that is accounts, and in that I am going to use the it statement, and this also takes two parameters. So first is a string, and I am going to give the name should be possible to deposit amount, and after that I need to pass on the function. Here. So first thing what will I need is that the account. Okay, so I will fetch the first account from Ganesh. So you should be familiar with the Ganesh, and you should start Ganesh before your test. So I have already started my Ganesh here. Okay, and after that I need to fetch some accounts from Ganesh. That is my first account. Just I need for first account. So write down the variable for that to store your first account address and its balance. So balance before the transaction is my variable that I'm going to use, and with the help of web3 I'm going to get the accounts balance from account 0. After that I need also a variable mortgage instance. So I am just creating a variable here, mortgage instance, and I need to check that whether my mortgage smart contract is deployed or not. If it is deployed, then I will proceed, else I will return. So just mortgage dot deployed. So if it is deployed, then I need the function instance. Okay, and that instance I will save in my variable, that is my instance. Assign your deployed contract instance here and just return this instance. Okay, now what I need to do is that I need to check the deposit function. For that I need to again call the then function. So I will write down the then, and in that I need again the instance of the smart contract. So write down the function and give the any name and assign that instance to your any type of variable. And just write down return and use your my mortgage instance variable dot deposit and pass on the 1 million amount that you want to deposit. Okay, after that I am going to also call the get balance function. So just again write down the then function and call the your my mortgage instance, and using that my mortgage instance call your get balance method from your smart contract and pass on the balance before transaction. Okay, after that I just need to assert these two statements here using assert dot equal. So just write down the then function again. So write down then function and pass the balance there, and assert dot equal, pass on the balance that you get and the balance that you have passed on manual. So assert statement actually checks the system generated output and the output you wanted, so it will check the equality of that, and if it is equal then this test should be marked as a passed or it marked as a failed. Here I need to pass some string. There should be 1 million amount for the address. Okay, so now I am done with my deposit.js. So I need to run this file. So for that just open your terminal, and in that terminal you need to compile your project using truffle compile command. Okay, so now it is compiled. Now you have to migrate using truffle migrate command. Now it has been deployed on your local Ganache network, and now just run the truffle test. So I think there is some error. Just need to check with my node module things. So now I think there is a spelling mistake of artifacts. So just run again the command again. Let me check this. With the error. So you should be familiar with the errors also. So now again run your truffle test. Now here you can see that it is successfully passed that test. So this is how you are going to write down the test cases for this project or another project. So this is just an example to write down how to write down the test cases for in the truffle and how to test them. So in the next lecture we will start with our front end. Thanks for watching. Welcome to this lecture. So in this lecture we are going to write down the front end for our project. So we are going to use a simple JavaScript and HTML language for our front end. So for that we need to start with our folder first for the front end. So just create a folder and give the name app, and in that app folder we need to create a JavaScript folder and one HTML file. So create a JavaScripts, and we need a design file, that is HTML file that will contain our design, that is index.html. And in that index.html we will design all the stuff like tabs and input fields, everything. So for that, first of all, what we need to do is that we need to write down the doc type, and HTML. So after that, start with your HTML tags. So start with your HTML tag. After that, write down the head first, and in that give the title to your page, that is a mortgage demo. And after that we need some reference CSS files that I already copied in a notepad, that I'm going to paste here. So just copy this code here and paste it here. After that, just copy the scripts also. Okay, so now we are done with the scripts and links. After that we need to create the body here. So I have written down the body tag here, and in that I'm going to use the class container. So if you're familiar with the HTML code, then you can easily do and understand this code. So first of all, in this container, what I need to do is that I need to create the tabs like sections A, B, C, D. Okay, here I used the h2 tag, and I'm aligning the style, that is just text align to the center. Now I need to use ul tag for the navigation tabs. So use class nav tabs, and in that I'm going to create 4 tabs using li. So make the first class as an active class, so it will be shown to the user first. Double quotes, make the active, and in that just write down a data toggle, and I need to use href section a, so that I can call this li from our app.js. So that's why I used href here, and then I'm going to give the id as a home tab, and after that I need to give the icon using I class, that is a fa class. Write down the class, double quotes, fa hyphen user, and give the name as a homeowner. Okay, so just copy this for the section B, and just change and remove this class because other class is inactive, and write down the just home tab to bank tab, and give the logo of university, that is a FA university, and give the name as a mortgage holder. So again copy and paste the same li for section 3 for our third section, and this time give the name to this section as a section C, and D also. Change the name to the insurer tab and IRS tab for fourth section also, and change the name here to FA user and FA suitcase for IRS, and change the name for third one to the insurer, and for the last one give the name for the fourth tab is IRS. So now here I done with my UL and LI tabs. Now what I need to do is that I need to create a div for each section, and for that I am going to write down the div, and in that I am to write down the class tab content, and in that same write down the div for that particular section A, and give the class as a tab pane fade inactive, and all this I will copy 3 times for class B, class C and class D. Okay, now what I need to do is that I need to write down the code in this class A. So I will use the another div, that is a, and I will assign that div a class, that is panel, and the panel is a primary panel having the margin top one, and in that I am going to use the panel heading class for another div, and use h3 tag here for the panel title, and give the class here, that is a panel title class. Okay, so after that I need to write down more code. Okay, for the panel primary and for the panel body. So now what I will do is that I will copy and paste this code. I will pause the video and I will come back after the copy and pasting of the code. So now I have copy and pasted the section A code. So you can see here it has all the bootstrap classes and things that I already copied. This is a big code, that's why I used copy and paste method from my notepad. I already designed this project HTML. So this is the code, so you can refer this code from our project source section from the portal. So now next is I need to write down the class B, and for that I have already written down the div for the section B. Now I have to write down the internal div, so I will start with the internal div, and I will use this bootstrap class called panel primary. So it will be the same like our class A, but there are just some minor changes that I have to do in this class B. So this is all the bootstrap classes that I am using here. If you are not familiar with the bootstrap classes, you can Google them. Here I need to give the title, so I am using this class panel title and I am giving the account details. Here now what I need to do is that I need to create another div that will contain the panel body. So for that I am going to use another bootstrap class called panel body here, and in that I am going to create a table. So create table, and I will use the bootstrap class called table script. and in that I'm going to create table body using tbody tag, and in that I'm going to use tr tag and td tag. So td account address, and give the id to this, that is bank account. Just copy this tr tag and paste it here, and change the name to the total mortgage amount, and change the id here, that is the total bank balance. Again copy and paste this tr tag, yes, and give the name outstanding balance, and change the id to outstanding bank balance. So now I need to create another table here. So again the same code here, I will use this div I need to check this div here. Okay, so I will create here a new div, and I'm going to use the again same bootstrap class called panel primary, and I will create the panel body using panel body bootstrap class. So another div, and in this div I need to create another table right here. So I'm going to create another table using same bootstrap class that we have already used. Above that is a table stripped, and in that we need to create tr tag, so I have copy and pasted here. So I need to define the th tag in tr tag, and in that I will use column span of 2 here, and going to use style text align to the left, and I will do that using loan contract. After that I will copy and paste the above tr tag here, and I will change to address, and I will change the id to the section B address. Again, copy and paste that tr tag and change this td to status and its id to section b status here. And after that, what we need to do is that we need to create another tr tag, and in that td tag, and in that I'm going to use button. So just use a button tag and give the id to it, that is approve loan. And I'm going to use the bootstrap class called btn primary, and this is the button name to the approve loan. So this is the section B. Now the same way, what we have to do is that we need to create the section C here. So for the section C, we are going to write down the same code. So just write down another div in the section C. So just copy and paste this from the section B, and in that write down the new div, and I'm going to use the class panel body, and in that I'm going to create a table. So that is a table class, and it's table striped class. And in that, the same way, we need to create tr and tt tags that we have done earlier. So just create a tr tag here, and in that tr tag create a td tag. So just write down the account address, and give the id as a insurer account. So give the insurer account. I have mistakenly write down other else. So just copy and paste it here for another tr tag and change the name to the total insured amount. And here I need to give this total insurer balance id. Okay, and again copy and paste this tr tag and change it to the amount paid, and change the id to the insurer balance. Another, again copy and paste the same tr tag and change this to the outstanding balance, and change its id to the outstanding insurer balance. After that, I need to create another div, that is I'm going to I just need to check here. So I just need to check where is the div closing so that there will be no confusion. So now create the div, that is a class. I'm going to use the bootstrap class called panel primary here. And in that I'm going to write down the panel body, and in that I'm going to create another div, and in that div I'm going to create a table, and I'm going to attach the class of table stripped to this table. And here what I need to do is that I need to do th column span of 2, and I will align this column using style to the left, and I will give the name to the as a loan contract. Again I need to create a new tr tag here, and in that td tag I need to pass the address and id as we have already done above. It will be the same, so give the id here as the section C address, and just write down tr again for the status for the section C to get highlighted. So status, and just give the id as a section C status. So this is the class section C. Okay, and the same way we can write down the class D. So what we can do is that we can copy and paste the above code from class C, so now we are done with the section C, and the same way we are going to write down the code for the section D, and for that it is the same code, just a little bit of changes. So I'm going to copy and paste the section C, and we'll do the required changes. So I am pausing the video here, and I will paste that code and do the required changes, and we'll continue after that code. So now I have copy and pasted the section D code here and did the required changes. So you can see here. If you have any problems regarding the code, you can refer the code that is present in our portal, the source code. So this is the same code like a section C, just little bit of changes, and some more fields I have added here. So this is the index HTML file that have all the design that we required for our project. So in the next lecture, what we are going to do is that we are going to write down the app.js file. That is the main code file which will interact with our this index HTML file. So we will meet in the next lecture. Thanks for watching.
Hello everyone. So today we are going to cover a little bit of basics related to web3.js. What is actually web3.js and why we require web3.js. Okay, so first of all, this is the JavaScript file, okay, that we will require to interact with the blockchain. Okay, so everyone knows that Ethereum is a node based system, right? So on every node there is a copy of a blockchain, right? So whenever you have to pull up some information from the Ethereum blockchain or from that particular node, that time you have to query to that particular node about that data. Okay, and because of that we need to write the queries to pull up those data. Okay, but Ethereum nodes only speak a language called JSON RPC. Okay, they don't speak a JavaScript language or any high level language. Okay, so they speak JSON RPC. Okay, so here you can see that this is the JSON RPC code that I have mentioned here. Okay, so as you can see that this JSON RPC code is not a human readable. Okay, it is a very complex code that we cannot use to pull up the data because we cannot write such a data. That's why there should be another way so that we can interact with this nodes, okay, or this JSON RPC. So because of this problem, actually whatever maybe the problem faced by the developers, they developed this web3.js JavaScript. Okay, it's a JavaScript which they use to interact with this JSON RPC. Okay, so web3.js hides these nasty queries below the surface, so you only need to interact with the convenient and easily readable JavaScript interface. Okay, so you can only have to write down the code in a JavaScript. Here you can see that this is the JavaScript code. This is a very human readable, and you can do this coding by yourself also. It is a not complex one, and there is a not too much amount of data here. So this is like a URL to the remote web server for your API calls, okay, in a traditional web app. Okay, so everyone knows that if we develop an iOS app, okay, and whenever we want to interact with some server, we need an address of the server or web APIs. Okay, from those web APIs we can pull up or send the data to the particular server. So just like that, this web3.js actually help us to get or send the data, or it will help us to interact with the Ethereum blockchain. Okay, so but how we are going to talk to the Ethereum based blockchain or that particular data? So in the last lecture, I think so, we have seen that the folder structure and how we are going to install this front folder and all that stuff we have seen in the last lecture. In that folders also there is a one particular folder that we have made that is called the contracts. And what we have done in that contracts folder, that we copy some JSON files from the build folder that we have compiled earlier, right? And we have copies those JSON files, those we got after the compilation, and we copy those files and paste that files or those JSON files into our that contracts folder, right? So why we did that? Because those are all ABI's files. Okay, so as I mentioned that there is a JSON RPC thing, okay, and we cannot interact with the JSON RPC directly, so we need an ABI to interact with the data. So because of that we need ABI, and then web3.js will talk to this ABI, and then this ABI will talk to that particular
blockchain. Okay, so this is the flow of this. Okay, so basically it's as I just mentioned, it's a representation of your contracts. Okay, that is a Solidity code, but that Solidity code gets converted to .json uh, format, and that JSON format you can understand. Okay, after that there are many numerous things by which you can interact with these Ethereum nodes also. So some of the ways are like you can write down the code in your in or that script in your project, and you can interact with that particular node also. Okay, or you can use things like MetaMask or third-party tools like Infura or something like that to interact with this uh, Ethereum nodes. Okay, so also that if you want to talk to this blockchain nodes, that time you also need the port numbers, right? For Ethereum main blockchain or for the test RPC, you have the port 8545, and for the Ganesh you have the port 7545. Okay, so and the main thing here is that your blockchain node must be running to talk to that node, because if blockchain or that particular machine is off, then you cannot talk to that particular blockchain using web3 or any ways, right? So this is the thing. Okay, so let me tell you about the tools, okay, of this. Like I told you about the MetaMask, so you can go to this Chrome store, web store, and in this web store go to this extensions. In this project we are not using the MetaMask for any of our transactions. We are going to directly use our scripts in our code, but many of the applications in the future that we are going to build, or you can see on internet, you will find this MetaMask thing. So just find this MetaMask. Okay, and just click on this MetaMask. So here you will find this extension, and yes, just you have to install this. I have already added this MetaMask here. Okay, so this has just an accounts. You have to give your passwords, and so they will create the accounts on the MetaMask. So this is the Chrome based or Firefox based extension that you can use to interact with the blockchains. You does not need to code anything or something like that. This is the third party and very good tool which is developed by this metamask.io. So this is very helpful tool that you can use. After that, there are some also subnet of the Ethereum like Infura that you can use. Okay, let me show you. So this is the scalable blockchain infrastructure that you can use for your Ethereum based projects. Okay, so many of the time what is the problem that people get is that if you want to actually run or download the actual Ethereum main node, so that time you will get the problem of syncing, because the main Ethereum node is actually very huge. I think it's probably current size of the Ethereum blockchain is around 70 to 80 GB, okay, gigabytes. So that is a very huge, and so people will get very tired, and they get very bored because of the sync problem between your nodes and the main node. So many of the time people actually go for this Infura. Okay, so by using this thing you can also able to interact with the main node. So this is a free thing, So you can go and just inject their one line of code into your project, and you will be able to interact with this. Okay, so in the next lecture we are going to use this web3.js to interact with our contracts. So we will meet in the next lecture. Thanks for watching. Welcome to this lecture. So in this lecture we are going to write down the code for our app.js file, and for that what we need to do is that we need to create a new file in this JavaScript folder called app.js, and in that file we have all the related code that we are going to write down. So first of all, we will write down the variables that we require for this, like accounts, after that owner account, bank account, insurer account, and IRS account. So these are the variables that we need for this file. After that we need to pass on the default gas value. So for that I am mentioning the default gas value, that is 47 million. And after that I need to write down the another variable for loan contract address. So loan contract address, and so now I need to call the mortgage.json from the build folder and pass it into the constant variable, that is artifact require this path to the build folder. So write down this build dot contracts slash mortgage dot contracts slash mortgage dot json. So we are referring this JSON file for our ABI. After that we also need the truffle contract, and for that I am writing down another variable. So constant required truffle contract in that, and after that I need to write down another variable using let. This time I'm going to use the let, and in that mortgage, and I will pass my artifacts here. So and the next stage is to set the provider of the web3. So for that I will set mortgage.set provider. So whatever may be the current provider available at that time, that I will set it in this line. So web3.current provider. After that I need to inject this web3 using onload method of window. So window dot onload, that is equal to function. So in this onload function, what I'm going to set is that my current Ganache provider, that is my localhost provider, that I'm going to set it up here using HTTP provider. Before that I need variable web3 and require web3 here. And here now I need another variable of web3 in which I am going to set the path using new web3. And in that web3 dot providers dot http provider, and in that I am going to pass my Ganache localhost address, that is http localhost, and the port number, that is 8545. After that, web3.eth dot get accounts, and in that function pass on your ERR and accounts. So this will get the accounts from your Ganache, and just give the if condition here, that if error is not equal to null, then just alert the user that there was an error fetching your accounts. And just return nothing. And if the account start length is equal to 0, then also alert the user that couldn't get any accounts. Make sure your couldn't get any accounts. Make sure your Ganache client is configured. Your Ganache client is configured correctly. And here also return nothing. Now just assign your accounts is equal to ACCS, your accounts, and assign the first address to the owner's account, that is owner's account from account 0 means the first address from your Ganache. After that, the second account for your bank account from Ganache, and third account for your insurer, and the fourth account is for your IRS. That is account 3. So now we have added up the accounts to particular account owner, bank, and everything. After that, we need to call the HTML tag using $. So use $ here and call the owner's account and set the owner's account that we have just written down above using HTML owner's account, and just like the same way copy and paste for the 4. Change the second one to the bank account, and third for your insurer account, and fourth is for your IRS account. After that, I also need to get the value from bank account, insurance account, and IRS account, and for that I am also going to use the $, and in that I am going to write down the pay image address, and in that I will need to change the HTML to the value, and for the pay insurance address, so after that I just need to check the on click methods using dollar. So whenever user clicks on deploy loan contract button, this will be called. So we use dollar, and in that call hash deploy loan contract dot click. If this is clicked in your HTML, then run this deploy loan contract method. Write down deploy loan contract, and same for the now I need to write down this deploy loan contract, and in that I need to pass the owner's account and default gas to the mortgage contract. So I will use the mortgage.new, and from which account, so from new, from owner's account, and I also need to pass the default gas value that we have already declared above, and just write down then. So after this I need the loan instance, so I will write down the function, and in that I will pass the loan instance, and in that I need to pass that loan instance address to the variable, that is loan contract address. So I am doing it here, just pass your address here. So now I have the instance of the loan contract address. After that I need to call the section addresses, right? We have written down the different sections like section A, section B, C, D. So I am now writing down the code for section A address, and I am calling that HTML using this code. Address card, and with the plus sign I need to check the target and on click to get the loan data. So I will write down this code: A target hash, on click, and get the loan data, and in that loan data we need the loan instance address in that. So now I get the address here. After that I will return false. And I need to href the loan instance dot address. So write down the loan instance dot address, and again concatenate with the loan instance address. So this is a little bit of complications of signs here of the tags, a tag. So just be careful to when writing down this type of complex tag code. Okay, so now I am done with the section A address. So for the same I need to write down for the class section C, B and D. So I can copy and paste these things. So just this code is the same for each and every section. So now I am done with that code. Now I need the section transaction hash. So for that I will use again dollar, and in that I will call that section a hash transaction hash. So transaction hash is nothing but whenever transaction happened, the string that you get from the ganache or from any node is called transaction hash. So this is the code that I am writing for my HTML to set. And in the next I need to again concatenate my loan instance dot transaction hash to this, so that way I will get the transaction hash. After that I will need to write down the then function to set the status in that. So I will write down then, and in that I will write down the get status here. So in this I will get the status, and after that again then function, and in that function I am going to write down another variable in which I am going to set mortgage loan contract address using mortgage dot at loan contract address. I will also need to get the balance from owner's account. Dot then and in that just call using $owners balance dot html data dot c as html so data.c at 0 positions means the first position from where I am getting the owner's balance. So now I am done with my deploy contract function here. So after that I need to write down this get status method, which is I have declared here. So write down the function for that. So function get status, and in that get status function I am going to check by the condition of if else that what is the status, whether it is initiated, submitted or approved. So for that, first of all get the loan contract address using this line, and after that just get the loan data, and in that loan data, when we get this loan data from the contract, then and then we can check the if condition. So just check that if data at position 7, so this position is nothing but the position which is present in our smart contract get loan data, just like monthly PI, monthly tax, and something like that. And in that I'm going to set the status of all the 4 section to be initiated if it is equal to 0. Right, we have already mentioned the statuses in our smart contract, that if it is a 0 then we will set the status, or we will say the status it has initiated. So if the data at position 7 is 0, we will set it to initiated. So make these changes to ABCD, and just like the same way just write down the if else statement and just check the condition now to the 1 and change the status to be submitted. Just write down the submitted here, just copy and paste the things, and again copy this else if statement for our approved status and copy and paste this again. So now I am done with this get status also. So now what I need to do is that I need to write down the function to submit the loan. Okay, before that I need to write down this call using the same thing, that we use for deploy a contract, and here I will call the submit loan function that I'm going to write down just after this. I'll just submit a loan. So write down a function called a submit loan. So as we have already used many variables in submit loan in smart contracts, just like the same way we are going to use all those variables here, but here just we need to multiply these values with the 100. So first of all, get the loan contract address, and after that the property address using variable address of a property, and to this address of a property just add the value from hash property address. After that, purchase price for that property. So declare another variable for purchase price and get the price value, and just multiply that value using 100. So we need to declare all the variables as same as that we have declared in our smart contract. So this is little bit of a lengthy, but we have to do it. So hash YR, and that is year terms, and just multiply that by 100. And after that, I think there is a interest, so just copy and paste it here and write down the interest here, and just change the YR to IR. Again, copy and paste the same thing and change it to the loan amount and change it to LA. Okay, and again copy and paste the same thing and change it to the annual tax here, and change it to 80. Again, same copy and paste for our annual insurance, and change it to AI. Again, copy paste for our monthly principal, that is monthly PI. So just change it to PI, and after that for monthly tax, change it to MT, and monthly insurance, change it to MI. So now we have declared all the variables and save the value from our HTML text boxes. Now I just need to submit this to those variables and send those transactions. So I need to again declare all those variables here. That is a purchase price, after that loan amount, after that annual tax, After that, annual insurance. After that, monthly PI. After that, monthly tax. After that, monthly insurance. And bank account. Also we need insurer's account and the IRS account. And just need from which account, so owner's account, and pass the default gas value to this function here. And then again write down then and pass your transaction hash to this function, and just set the get status, call the get status function that we have already written down above. After that, in this again I need to get the loan data here. And just we did above, and in that we need to get different parameters here, like total bank balance, outstanding bank balance, and stuff to show to the user. So just give dollar and hash total bank balance dot html and get the 8th position from the list. Now this time divide by 100 to show you on the UI correctly. That's why I am dividing it by 100 into 12 into 30. So 12 is the months and 30 is the year, 30 years, for 30 years. So this is the fixed value that I am passing here. After that, bank balance dot html 0, and again I'm going to copy this and paste it here and just change to outstanding bank balance. Again I'm going to copy and paste this and change it to the total insurance balance here. Let's change the text here, that is the insurance balance. Again just change the outstanding insurance balance. Again just change to 9 and again copy and paste this for the data at position 10. So this time for the IRS balance, so just change to insurance to the IRS, change the value to the 10, and IRS balance in, so wherever you find the insurance just change it to IRS and in the last line also change it to IRS and just change the value to 10. So if there is any problem comes any, that for that we need to add the catch statement. So catch function e, in that write down the console.log. So by this way we are going to log any errors into the logcat. So this is the code for this. Okay, so now this is the code. After that, what we need to do is that we need to write down another function, and that function will be for the approve loan. So just copy and paste this thing and change this to the approve loan. So now I need to write down the code for this approve loan. So just write down the function for approve loan. So here I need to get the loan contract address first in each and every function. So first line will be the same as of above function, and in that I'm going to call the approve and reject loan function that is present in my smart contract, and send the transaction there. So send the transaction to from bank account, because this is not the owner's account. This time we need to pass the bank account's address and default gas value that we have already mentioned above, and we also need to pass the transaction hash function to the then, and then we will set this get status. So this is the approve loan function. After that we need to write down the get monthly payment function. So just copy and paste this again and change this to get monthly payment. And we need to write down the functionality for this also. So write down the function that is for get monthly payment, and here also again I need to get the loan contract address first, and need to store into some variables to call the functions. So use ct.get loan data this time again, and just pass the then and pass the data, and in that again use the $sign to value, write down the value image dot val, and in that I write down the get the data from its position and divide it by 100, and we can copy and paste this thing for data 9 and data 10. Let's change to value insurer and IRS. We need to change insurer and change it to 9, and again copy and paste this thing and change it to IRS. Okay, so this is the get monthly payment function. After that, what we need to do is that we need to copy this again, and this time I'm going to write down the complete payment functionality. So call the complete payment functionality, and I again need to write down the complete payment method. So in this complete payment method, I'm going to call 3 separate functions, because this is the big functionality. So I'm going to divide using 3 functions different, and I'm just calling these 3 functions in this complete payment. So first of all, the complete bank, complete insurer, and complete IRS, and I will write down this different function below this complete payment function. So after that, I need to what I need to do is that I need to write down these functions for complete bank, complete insurer, and complete IRS. So these are the simple functions that just like the same that we have defined above. So what I'm going to do is that I'm going to write down these functions by pausing the video, and I will show you all those functions. So right now I will pause the video, and I will get back when I am done with the rest of the functions. So now here you can see that I just written down the code that we required for this, like complete bank. So this is the same like the above code, just the minor changes, like I just need to minus the bank balance here, and same like for insurer. So this is the same as like insurer and insurers complete IRS. So these 3 functions are same. After that, I also written down the functionality for make payment, in that I just got the different variable for bank balance, IRS balance, and insurance balance, and I am sending the transaction from the owner's account here. And after that, I am getting the data for data like balance from the owner's account using this code. And after that, here I am checking the balance for that particular address, like bank account address, insurer's account balance, and IRS account balance using this code here. And I am also getting the loan data and checking the if else statement again for the outstanding bank balance for bank, insurer, and IRS. So you can see here, and this is the basic functionality for get balance. So again, the contract address first of all I need, and then I'm calling the get balance method, and I am passing the address for that particular account, and I am dividing the whatever may be the data that I am getting to display properly on the UI. After that, these are the some basic functionality like hex to string and truncate to decimals. After that, floor and do some. So these are the just basic functionality that I have written here that you can find on the net also. So this is it for the app.js file. So just what we need to do is that we need to call this app.js file in our index.html that we have written down up here. So this is it for this project. So in the next lecture we are going to run this project using our commands. So we will meet in the next lecture. Thanks for watching. So welcome to this lecture. So in this lecture we are going to run our project. So for that, first of all, we need this webpack.config.js that I have already copy and pasted from the internet and made some necessary changes. So for the webpack.config.js, for the more information you can Google it for the more information. And now we are going to run this code. So open your terminal and run your npm run dev. So this command will run. So copy this localhost and paste it here, or this will run automatically. So now here you can find that I have already installed the MetaMask and connected it to my private network. So for the MetaMask you can Google it or watch a YouTube video. This is just a Chrome extension that you can find on a Chrome store, which provide a Web3 injected Web3 interface for our projects to run correctly. So now I have already installed and done the necessary configuration of the MetaMask, and this is my project. So here you can see that this is the tabs that we have defined in index.html, like homeowner, mortgage holder, insurer, and IRS, and their table structure. So this is the total design of the project. Now I need to initiate the loan contract here. So MetaMask pop-up will come up. Just confirm this. So now here you can see that my loan is in the initiated status, and this is the transaction hash here. Now what I need to do is that I need to add the property address, like Miami, and purchase price is $200,000 that I have mentioned. Then I will calculate the monthly interest and principal amount and monthly tax I need to pay and monthly insurance. And here you can see that the total payment is $730, and I will submit this loan by clicking on this. Just confirm this MetaMask. So now you can go to mortgage holder. So again submit the loan. I think there is some MetaMask problem. Now again go to this, and here you can see that my total mortgage amount is displayed here. Now there is a total amount paid is a 0, and now I'm going to insurer tab, and here you can see that my total insured amount is also displayed here, that is 45,000, and my IRS tab, that is 18,000, and I paid nothing. Now I need to pay some monthly amount. So I will click on this monthly payment, and this is the calculation that it has given. The smart contract has given me that we need to pay the mortgage amount like 555.74. that is my main mortgage amount. After that I need to pay 125 rupees for my insurance amount and 50 rupees for 50 for my tax amount. Okay, now I need to send this amount to the particular tabs, that is the mortgage holder. So this will take some time. So again need to send. I think there is a MetaMask problem. So now it is transaction is confirmed, and here you can see that 555.74 amount is paid now. And just like the same way, I'm going to send that amount to this third address of the insurer, and for the fourth one also. So just go and check the insurer. So again just click on that. I think MetaMask is giving me today some errors, so just need to reconfirm this by clicking again. So sometimes MetaMask gives you some errors. So now here you can see now it is paid here now. So this is the monthly, I just paid it here. Now what will I do is that I will complete my mortgage payoff, and here you can see that my mortgage amount that is remaining here, and my insurance amount and my tax amount I need to pay. So I can pay in a one stroke. So that time I just need to click on the send for these three again. Just check the IRS. So I think there is a double click, I need to click here. So now here you can see that my total amount is now paid here. Again go to the insurer, click it. I think my MetaMask is giving me an error this time, so I am clicking this on double time. So this is the MetaMask problem. Sometimes you will get, sometimes you will not. So just do that. So for my project or my MetaMask, I am doing this. Now here you can see that my mortgage payment is now totally paid. My insurers also totally paid. So this is how you can do the mortgage processing thing. So this is the basic example project that I have shown here. So now this is it from me. Thanks for watching. Congratulations to everyone for completing this project video successfully. So in this course what we have seen is that we see that how to create a mortgage processing smart contract, right? We written down the smart contract code, which actually replaces the regular system that is actually present right now in the world, and we design a smart contract which takes care of the functionality of a bank and bank system. So in the first section we actually covered the basics of blockchain and basics of a Solidity, and what is Solidity features and everything that we have covered in the first session. After in the second session we write down the code for our smart contract, that is a mortgage smart contract, and we also saw the softwares which we required to blockchain development, right? And what is the test structure and truffle structure, and what is the structure that we need. And in the last section we actually gone for the index file, and we design how our application will look like, and we design an HTML pages in that index.html file, and after that we go on for the app.js section, and in that we written down the code, and in which we used the web3 uh, injection from the MetaMask, right? And we run the project using Chrome browser, and we use the MetaMask as a web3 provider in that session. So this is how we actually done this project. So again, if you have any problems and if you have any queries, please let us know, so we can give you answers, and we can guide you if you stuck anywhere in the process of the project development. So thanks again. Thanks for watching.